Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section of the class, we're going to switch gears yet again and start to begin to talk about a new topic entirely, and that's the topic of polar coordinates. So the next 2 or 3 sections are going to deal with polar representation of functions, and this is the introductory part of that, dealing with polar coordinates. So in this class has sort of been a hodgepodge of things, and that's how Calculus 2 is when you get towards the toward the end of it. You start to talk about your trigonometric functions, your inverses, you start to talk about all of your surface areas and your arc lengths and all that stuff sort of disconnected. And then you come into the topic of polar coordinates, polar equations, and specifically the culmination of that in Calculus 2 is doing the integrals in polar coordinates. And sometimes that can trip people up because it's a new concept. It's not something you're used to thinking about too much. But I have to say that this polar stuff, all of this stuff is somewhat important if you're going to go on to engineering or physics or any kind of a science-based career, okay? But polar coordinates, I really want you to learn this stuff, okay? Because having gone through engineering and gone on and done some things, really that is very powerful stuff. And some of the other topics in this class you may or you may not ever coordinate, or a Cartesian coordinate is the one that you've learned about all your life. You have 2 numbers, x and y, that define that. So if this is your graph, that you've grown up knowing all the time, it's the xy graph, right? And I have a point here, okay? And when you learned about this point, you were taught that this point can be represented by 2 numbers, x, comma, y. Okay, now you're very comfortable with this idea now because you've been doing it for so long. But when you were first introduced to this was a pretty far out concept, okay? That you would take a point, you'd put it on a graph, this giant open angle here. Theta is always in reference to the x-axis. So if I have a point way down here, the angle is going to be all the way over here, you see? So that's how you have to do it. That's what polar coordinates are, okay? So it's reference to the x-axis. Those are for positive angles, okay? Now you can always have you can also have a representation of negative angles as well. Okay, if I wanted to use a negative angle, I could also do that. Okay, so it would be r, and then I would have a negative angle. Okay, so the angle can be expressed either by going all the way around. You should know from your trig and your introductory calculus and all of that in trig, in radian angle measure, you can continue on past pi over 4, and you can go all the way around another full circle and arrive back at the same point. And one full circle in trig is always 2 pi radians. Any circle you make is always 2 pi radians, okay? So in theory, I could add another 2 pi radians to this angle, and I would end up in exactly the same place. So what would that look like, okay? So what I'm trying to say is that this representation is equally valid. I have a common denominator here. So 16 pi over 4, when you do this division, is equal to 4 pi, okay? So what would that be? That would be 1 comma pi plus 16 pi is 17 pi divided by 4, okay? 17 pi divided by 4, okay? So this representation, 1 comma 17 pi over 4 for the angle, this representation, 1 comma 9 pi over 4, and the original representation, they look different, but they're exactly the same thing. They have different angles, but because the angles are just 2 pi going around the circle 2 pi, which is a full circle, they actually describe the same thing. So, and the same thing goes for subtracting 2 pi and subtracting 4 pi and subtracting 6 pi and so on and so on. So I'm adding them here, but you could just as legally subtract 2 pi. So instead of adding 2 pi, I just subtract 2 pi. Okay, and I get back to where I started from. So any polar point you have, you can always add any multiple of 2 pi, 4 pi, 6 pi, 8 pi, so on. You can also subtract them the same way I'm doing here, and you'll get different points, but they're going to all represent the same thing. Okay, so the long and short of it is, the thing that so you'd be able to take his work or her work, okay, and convert it into polar coordinates, and then continue on from there and do your own work. And likewise, you might be working in polar coordinates, and then somebody comes back and says, well, that's nice, but I need to work in Cartesian for whatever reason, and it would be nice if you could convert all of his work into Cartesian. And it should be possible to do this because they're just 2 different ways of saying the same thing. So it's just like converting from miles to feet or centimeters to kilometers. You can do it, it's just you have to know how to convert them. So that's what we're going to be able to do here. We're going to learn how to convert the angle, which is just the angle from the x-axis, either positive or negative, okay? And so I know what r is, and I know what theta is. I just plug it in here and I'll get an x, and I'll plug it in here and I'll get a y, and that's the corresponding x and y. Now why does this work? Why does this work this way? Well, if you remember back, let me just draw a quick little picture here to the side. Okay, if here's x and y, and here's the point I'm interested in, okay, and obviously it's going to have a radius here and an angle here, okay. Well, what you're doing here, you see, this is r and theta that I'm given, and I like to convert to Cartesian. I like to write it this way. Cosine of I keep writing a theta here. Cosine of theta, you could say cosine of theta is equal to the adjacent value over the hypotenuse, okay? The hypotenuse is r, right? So you could say r here. So if you were to solve this thing for the adjacent value, which is this, which is what you're trying to find for the value of x, it would be r times cosine of theta, okay? So it's really just triangle trig is all it is. That's all these things are right here. And so by analogy, the same exact thing is true here. This value, which is the y formula, is equal to, the distance between any 2 points in the rectangular system is the square root of delta x squared plus delta y squared. The difference between the points in x and the difference between the points in y, square them, add them, take the square root. This is exactly the same thing. It's just I didn't write the square root here. I'm writing it as r squared is equal to x squared plus y squared. Because you're always measuring this from the origin, that's just the definition. The point you have here is always, the length r is always from the origin, so delta x and delta y are just going to be equal to the values of x and y of the point, okay? You square them, you add them up, you take the square root of the triangle here, because remember, this is a right triangle. Tangent of theta is equal to opposite over adjacent. Opposite is y, because this is y, and adjacent is x. So all I've written here is the exact definition of what the tangent is in terms of a triangle. Tangent of theta is opposite over adjacent. That's all it is. The only reason that this one's a little bit tricky is you really have to be careful about your quadrants, okay? And we'll see it when we get to the problems. But basically, when you're given an x and you're given a y, okay, remember back to the very first section on the inverse tangent function. Because what you're going to end up doing is you're going to divide y. That's all I'm trying to say here. You got to make sure, because your calculator is only going to return this. Your actual angle may be over here, depending on the values of x and y. Okay, you can do this stuff all day, but it really is helpful just to work some problems. So let's do that now. Okay, what we're going to do is we're going to plot the point in these problems. We're going to plot the point, okay, which is going to be a polar point. Okay, and we're also going to find another equivalent polar point. So r squared is equal to, what do I have here? I have 2 times the square root of 3 squared plus negative 2 squared. Now what do I have in here? The 2 squared is going to give me 4, and the square root of 3 squared is just going to give me 3. Okay, and negative 2 squared is just going to give me positive 4. So r squared is equal to 12 plus 4, which is going to give me 16. Okay, and then to actually find what r is, which is what I'm going to need, I just take the square root of 16, which is here. Okay, the point is going to be somewhere in that quadrant down over there, and you just want to make sure that whatever angle you get is going to give you that as the right answer. Okay, it's going to give you the right quadrant. And there are going to be some cases when your calculator will not give you the right quadrant. So that's why you have to be careful. So let's just say, basically the way you do these is you start marching around the unit circle and plugging in values until you find the right value. So let's just say if theta is equal to negative pi over 6, what will we have? Okay, if I did that, remember tangent is equal to give us what we said it should give us. Okay, now this could be the right answer for theta, but the other thing we have to make sure is, does it agree? Okay, does the quadrant agree? Okay, look at this. Where would this angle be? Negative pi over 6. Well, positive angles are this way, negative angles are this way. Pi over 6 is roughly 30 degrees, so that does tell me that it's right there. So it's in the right quadrant. You see, this angle, negative pi over 6, lies down here. It exactly agrees with the quadrant that the point is actually in, x comma y. So, because they agree, sense to you here. 5 pi over 6. This is roughly 30 degrees. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And my drawing's not exactly to scale, but it's roughly right, okay? So, short answer is, when you're doing this part where you're converting from rectangular to polar, getting the radius is easy. X squared plus y squared, get your value of r. But when you take the ratio of y to x and you calculate something and you're taking that arc tangent, Go ahead and find an angle that works, but when you find that angle, always compare numbers, just like x and y, except it's r comma theta. A distance from the origin is r. Theta is just the angle from the axis. And you can have many different representations because you can continue adding 2 pi or subtracting 2 pi or 4 pi or 6 pi to get different angles. We also learned how to convert polar to rectangular and rectangular to polar, back and forth, and we've shown several problems to do that here. So those are central skills that you're going to need to tackle the remaining sections in this class, and also in your furthering your education and also in your career.